So let's suppose that we have our usual regression where we have two variables explaining the outcome y. So we have x1 and x2, and we have a hypothesis, a joint hypothesis that we want to test, that beta 1 equals 0 and beta 2 equals 0. How can we test this? Well, we've seen from Stock and Watson that one way we can test it is to construct the F statistic and reject the joint null hypothesis when the p-value of the F statistic is less than 0.05. Implicitly here, we've constructed a test statistic that has a distribution. It has a distribution because different samples produce different values of this test statistic. So we've constructed this test statistic, the F-stat, that has a distribution according to samples, right, for different samples. And the distribution is such that if the null hypothesis were true, and we set our significance level at 5%, then we would reject the null hypothesis, even if it were true, 5% of the time. That is, in 5% of the random samples. So that's our F statistic that we might set. Now, suppose instead of that F statistic, somebody proposes another test, a different test, at the 5% level. So they say, I have a different test, and it will reject at the 5% level. That is, we'll reject, using my test, we'll reject the joint null hypothesis. What's my test? Well, we'll calculate t-statistics for each one of the coefficients, and if those t-statistics are less than 1.96, we'll reject the joint null hypothesis. So we might say, is that a good test? Is it as good as the F statistic? And the answer is no, because that test that that person has proposed, we will reject the joint null hypothesis too often. So to show that, pretty simple, just a few steps of algebra, we ask, well, what is the probability that the t-statistic is greater than 1.96 for the first coefficient, or it's greater than 1.96 for the second coefficient, or it's greater than 1.96 for both of those coefficients? What is that probability? Well, that probability is just 1 minus the probability that the t-statistic for the first coefficient is less than 1.96 and the t-statistic for the second coefficient is less than 1.96, assuming that the t-statistic's distribution, remember, the t-statistic is a random variable because it varies with each sample. So if we assume that those t-statistics on the two coefficients are independent, then the probability that they're both less than 1.96 is just the probability that one is less than 1.96 times the probability that the other is less than 1.96. So we already know from our knowledge of the t-statistic that the probability that it's less than 1.96 is, in absolute value, is 0.95. So we have 1 minus 0.95 times 0.95, which is 1 minus 0.9025, which is 0.0975, which is bigger than 0.05. So we'll be rejecting almost 10% of the time. We'll be rejecting the joint null hypothesis too often. So the test, we think it's at the 5% level, but then when we actually calculate how often we would reject the null hypothesis, if the null hypothesis were true, we'd find we'd be rejecting it 9.75%. So that's why this is not a good test.